And really, we wanted to kind of get rid of the hassle that's involved with prototyping and moving things to production and things of that nature. So generally, at least, I don't know about you guys, but for me, my typical job is something along these lines. So I have a data set. Here is MNIST. You guys probably all know what that is. It's a pretty popular handwriting recognition data set. And so, you know, your boss comes along or there's some project that comes along and says, here, we have this data set. We want you to build a model based upon this. You optimize some hyperparameters, you figure out what kind of hardware you want to use, and then you end up with, you know, the best model to production. And that's great. And, you know, you do it once and you're like, okay, this was fun, this was nice. But that's not usually how it goes. What ends up happening a lot of the times is 2 months later, your manager comes to you and say, you know, that model you built 2 months ago that you totally forgot about, that was great, but let's try and either retrain it on a different data set, make it part of another model, try a different training approach, or worst case scenario, you are not going to look at this model, but 2 months later, someone else is going to come in and be like, okay, what did Stephanie do? And yeah, so there's a lot of hassle that's involved with this. You have to go and figure out where all the different artifacts are, if the person had saved any tensor board information and logs, where the data set is stored, or if you have to go download it again. And there's just a lot of hassle that's involved with this. And so what Studio is intended to do is to kind of take care of this last part here. So this is the part where we have model management, including taking care of sort of your environment, files, logs, any artifacts that comes with it, hardware selection, hyperparameter search, running things locally or on a server or in the cloud, all of this, and kind of trying to speed up and ease this production pipeline. So yeah, so what is Studio.ML? So like I said, it's a tool for managing, sharing, and reproducing Python experiments. My favorite part about Studio is that it has minimal invasion in the code. So really, I'll be doing a live demo so you guys will see, but it should be as simple as, you know, you have a script, you run Python, myscript.py, you type in the arguments. All you have to do is change Python to Studio Run. So you do Studio Run, myscript.py, type in your arguments, and theoretically, Studio should be able to run your script and do all of the things that I promised. So managing it, sharing this, saving your work environment, and any artifacts that come out of your script. And of course, there's seamless local remote, like a server and cloud execution. I'll demo all of these things, and so it makes more sense. So yeah, oh, and like Paul said, I think there's like a Q&A button here. If you want to, feel free to type in your questions throughout this whole thing. I can answer them if they're fast, and if not, we can answer them towards the end. Yeah, so let's see. So let's get started with the demo. So all that I've done here is I've created a virtual environment. So if you don't really have experience with using virtual environments, that's totally fine. For me, it's just easier to maintain my packages. And so I activate my virtual environment, and then I've pre-installed Studio. You can either just do pip install Studio.ML, or you can clone it from the repo and then install it directly from source. Either way, so I went ahead and cloned it from repo and downloaded, installed Studio.ML. So let's see. So there are a couple of examples actually in the repo. So I'm going to look at a Keras example. And feel free to ask me to, you know, make my font bigger or something like that. So let's see. So let's look at train MNIST. So let me just change this. So this is just pretty straightforward script. You load the MNIST data set. You massage the data so it's in the right format. And then we create this very simple network here. Yeah, and there's not a whole lot going here. I'm sure you guys have all tried something similar or seen it if you have worked with Keras. By the way, Studio is not Keras specific, so it just has to be Python. So it works with PyTorch, scikit-learn, Keras, whichever framework you use. Okay, so traditionally, this is what you would do to train this model. You just run Python train MNIST Keras, name, and then as you can see, it's training pretty quickly. And MNIST is a really easy data set. So even with the simple model that I showed, and we're going to train it for 10 epochs, it should achieve pretty good validation accuracy. So yeah, so 93%, that's great. So like I promised you, Studio has minimal invasion of code. So all I'm going to do here is going to do Studio run, change to Python. And then one thing I have to do, because I've been playing around, is just add this for-skit flag here. All that this means is usually for Studio, it requires you to have a clean Git repo. So that just means that everything that you've changed, you should commit it. You can overwrite it with this flag. So yeah. So what's going to happen here now is that Studio is going to go through and look at your work environment, any data that might be involved. In our case, we're just loading MNIST straight from the Keras data sets. So it doesn't need to really look for that or package that. And then it's going to upload and store this in Google Store. And then, yeah, and then look, it's training. So again, 10 epochs, exact same code, and 93% validation accuracy. So same thing. And so what we can do is we can type Studio UI, and this should open up. So if we navigate here to localhost 5000. Alternatively, you can go to zoo.studio.ml. This should have all of your experiments here. So it takes a little while for this to populate, but as you can see, this top one here, this top experiment is the one that I just trained. Yeah, and so if you look at it, it has kind of the environment you can look at, the workspace, any output, model directory. So we finished training that, and so status is finished, and it kind of gives you the tail end of the log. So in this case, there wasn't much, and so it's right all there. So it's exactly the same as this here. And if you look at the code, what I did was I added TensorBoard logs, and so TensorBoard is actually integrated directly into Studio, so instead of having to go find where your TensorBoard logs are and then trying to launch the TensorBoard, just have this handy dandy button here, TensorBoard, and that should redirect you to a TensorBoard. So you can see here, you know, if you don't have experience with TensorBoard, that's fine. It's just an additional feature for those who want to use TensorBoard. Yeah, so this is nice. This isn't that complicated, and you can do this on your own local machine. So why do you care? This isn't that great. Well, so you can do more things. So for example, so in this code here, instead of loading the MNIST dataset directly from Keras datasets, what I can do is I can upload my local data. So I can tell Studio, okay, I want to keep track of this data. I'm going to create this library called MNIST, and I want to load the MNIST dataset into that. And this way, it can be completely execution space independent. So it doesn't matter if you're going to try to rerun this on someone else's machine in the cloud 3 months later. Studio should keep track of your data. So this time, instead of, so we have Studio run, again, force git to force our git repo. And then I'm going to capture once. And then I have this demo, this data set stored here. And I'm going to name, again, it was MNIST. And let's say we want to do hyperparameter tuning, because why not? We'll do hyperparameter tuning on the learning rate. Start from 0.01 in increments of 0.01 to 0.1. And then, yeah, let's see, do that. And then we'll just run the script itself. Okay, so this will probably take a little bit longer. So like I said, what it's doing is it's capturing this data set, our local data, it's compressing it and uploading it to Google Storage. And so if we refresh our web UI, hopefully at the very top, there should be another train MNIST Keras. Let's see. Actually, let me stop this for a second. So, all right. The reason why I stopped that was because I was doing a hyperparameter search, but I was doing it locally on my machine. And so that was going to take a long time. So let's get rid of that for now. We'll do that next. And just run a vanilla, just the vanilla train MNIST Keras.py, with the only difference being that we're going to be uploading the data. So while that uploads, I guess we can start another process. So the hyperparameter search. So what we can do is hyperparameter. Again, the learning rate, I'm going to vary it as before. And then I'm going to let the metric be validation accuracy, for example. And I'm going to execute this in the cloud. So in Google Cloud, with say number of filters equals 2. And then train, say examples, just train MNIST. Okay. So let's see if the other guy has uploaded its data. And so here, all that I'm doing is doing a hyperparameter search of the learning rate between 0.01 to 0.1 in steps of 0.01. I'm going to measure it on the validation accuracy. And like I said, instead of running things locally, well, that would help if I could spell correctly. But instead of executing things locally, I am going to do it in my Google Cloud. There we go. Okay, so this experiment here. So hopefully, okay, so as you can see, it's going out and getting a cloud instance, and it's kind of installing all the necessary things. Hopefully this should work. And this is my Google Cloud. Yep, like you can see it. So it's spinning up. It should spin up 2 workers. So it's spin up 1 worker so far, and then it should spin up another guy. And yeah, so I'm not just making it up. Okay. So, and what it does, if you look at the UI here, is that it's creating these experiments and it's saving it under this hyperparameter project. And so it's grouping them all together. So later on, when you want to go back and look at things, you can just refer to the project and see the results for all of the different learning rate parameters. And so I'll load. This guy is still waiting. I guess he's uploading the data. So this guy, if you remember, was the guy when we were trying to upload the local data. But yeah, so we'll let those guys run for a bit and we'll get back to it. So what are the main features of Studio? So we have it capturing experiment information, so the Python environment in which you're running, any files or logs that you're creating. And then it also does artifact management, hyperparameter search. So we have some fancy ones like CMAS, but also just traditional grid search. You can do queue-based scheduling, and there's also features for helping expedite pipelines for existing trained models. So hardware selection, this is kind of the default selection here. If you do an Amazon EC2, it selects the cheapest instance. Google Cloud Compute, you can configure it. If you have a server, it will select the free GPUs by setting the CUDA visible devices to just the ones that are free on the server. Yeah, and artifact management. So we were using this capture once to capture the data set. So what that means is as Studio is running the experiments, you don't want it to continuously capture the data, compress, and upload, because like you saw, it takes a little bit of time. But things like checkpoints, or tensor board logs, like those you want to continuously capture throughout the lifetime of the script running. And so those you do a capture. And then another thing that you can do, it's really simple to do, is to reuse. So for example, let's say I upload the data once and it's uploaded. Instead of having to upload the same data, MNIST is fine, but let's say you're doing ImageNet or some big, unwieldy data set, you don't want to keep uploading it. So you can just say reuse my experiment and then refer to the name of the key of the experiment. And yeah, so we're doing that. Okay, so let's go back to see how our guys are doing. So, waiting. Okay, so so here is the project hyperparameter search that we were trying to do. As you can see, some of them have finished. And what you can actually do is you can look at the tensor board for all of these experiments at once. And it should show you exactly how each of the candidates are doing. And from that, you can pick and choose. So we'll let that load. And so one of the newest features actually of Studio.ML is that it has Jupyter Notebook integration now. So let me just make sure my guy's connected. Okay, it's not. So let me just restart this guy. So yeah, so as a data scientist, I often find myself using Jupyter Notebooks just because it's easy and it's fast. And it's nice to kind of see, your input, your output, and kind of fiddle around with the code and immediately see how that changes things. So what we do is we use Magic. And so all you have to do is from Studio import Magic. And then, so let's say we have super simple x equals 1, incremented by 1, perfect. Let's say that's your script. All you have to do is now just run this here, and then you can go ahead. And so now this experiment, Studio is running this script now. And what it's going to do is again, do the same thing. It's going to kind of capture your work environment and the data that you're going to be using in this nothing, upload this, and then keep track of the output, all this information. So this way, if you're kind of running experiments through your Jupyter Notebook, which I have a coworker who does that, you can share kind of the results much more easily than, trying to either share notebooks or share outputs from notebooks or things like that. All you have to do is, okay, here's my experiment result from just my Jupyter Notebook execution. Yeah, and here you go. Tail end of the log, 2 printed, 1 plus 1. So yeah, so this is actually really cool and one of my favorite new features. So yeah, so let's see how this guy did. Okay. So who was this guy? So as you can see, so this guy here was the experiment where I uploaded my local data to MNIST, and now this data is here, stored here, and then later on, if you want to run other experiments, what you can do is you can run them by directly referring to this experiment key right here. So yeah, so we're nearing the end of the 30 minutes. So I just wanted to point out a couple of things. So the general architecture is, well, so it's not this simple. So you have your script and you have your file system, and all that you're doing here is, so you have your queue. And so we didn't do any queue-based scheduling, but if we did, you have your queue, gets back, and then the experiments are stored in database. I think it used to be Firebase, but we might have changed that recently. If we did, it's very recent change. And then any sort of artifacts such as the data or the checkpoints and things like that are stored in G-Cloud. And this part, so this part you can change out yourself. So technically you can check it out. Yeah. So yeah, okay, so I got a couple of questions. So someone asked if it's still open source. Yes, it's still open source, and I'll just show you the GitHub repo. And can I store the data on premise? Yeah, so like I was saying, what you can do is you can switch out the database for either storing the experiment information or even just any artifacts and things like that. So it is design so that, you know, you can make it private if you want to use it just for your own company. As a matter of fact, for us, we use this in-house, and so we have our own backend to store our experiments so that it stays private. Yeah, so let's see, Studio.ML. So this here is a GitHub repo. It's all open source. And yes, it will run in Docker environments. And we actually have this nice documentation where you can actually set up, actually answers most of the questions that you guys have been asking. So you can customize your work environment. Let's see, Docker. Yeah, so you can, I guess, okay, so it says you can set up a remote worker using a Docker container, but obviously you can run it in a Docker environment. Some of the servers that we have at Sentient, you're only able to access it through a Docker container, and so that was kind of one of the first few features that Studio did add on. So yeah, so the documentation is just docs.studio.ml. This is the GitHub repo. Please feel free to add any issues, any questions you have. You can either do this or you can join our Slack channel. So if you just go to Studio.ML, you can just sign up for our Slack channel, and Peter, who is one of the main developers for Studio.ML, he's really on top of his stuff, and he'll answer questions very quickly. It's very hands-on. It's actually really nice. Yeah.
About pipeline schedule inside Studio. Can I have a continuous pipeline schedule inside Studio.ML? Like whenever it gets new data, it will automatically train the existing model with new data.
So you can set up something similar, yes, but it's a little bit more complicated. Like it's not just like the default, you know, that you do continuous pipeline, Studio run. But yeah, no, that's actually a really good, if you want a more detailed answer, feel free to join us on Slack and ask there, because Peter will actually give you kind of like a step-by-step on how to do that. Let's see. Yeah, so join us on Slack, download Studio, try using it. If you guys have any other questions. Oh, and we have this quick poll.
Poll here as well for people. If you feel like answering, great. Thank you very much. If not, don't worry. Oh, another question we have. Okay, no, thanks. We'll get in touch on site. Okay. We also have an email address, right, Stephanie? Team@studio.
Yeah. So we have an email address. So it's team@studio.ml. And maybe we should add that to the website so it's easy to email us. But yeah, but like I said, you can join us on the Slack channel. We'll answer things very quickly, or also GitHub issues. Yeah, Peter tries to keep this under 50. So as you can see, we're getting close, but keeping it pretty good for now.
Does anyone have any other questions?
Yeah.
We're keen to get lots of questions or feedback.
Anything? It's Python 2 and 3 compatible for those who use Python 3. Personally a Python 2 user, but not biased. Anything else?
Looks like we don't have any more questions. So.
Oh, there's a chat.
Oh yeah. What's the Slack channel again? Can you just say that again, Stephanie?
I think it's Studio.ML. Yeah, it's Studio.ML. So what is it? Studio.ML.slack. Whatever. But yeah, if you want, you can go sign up for the here. You can you'll get an invitation. So sign up through this link that I sent in the chat, studio.ml.now.sh. And then you'll just type in your email address and you should get an invitation to the Slack channel.
Great. Any more questions?
Okay, we have a question. Does it have notion of workflow? Like I can set up workflow for training rather than writing whole training code in a single file. So I'm not 100% sure what you mean. Maybe if you can elaborate. So obviously you don't have to kind of write your code in a single file, but it does, I mean, it has the same workflow, I guess, as running any kind of Python script. So you don't have to keep everything in one file, but really you're just running one script. So in that sense, anything you can do Python script, you can do Studio Run script. Yeah, and then Paul, can we get the slides as well afterwards? I mean, I can just send them to you and you can send them out.
Yes, we will circulate the slides and the recording for everyone afterwards.
Yeah. So I mean, okay. So you clarified. I'm saying that I can write pre-processing code written by someone else, so I can use that code and then use your training code. Yes, so you can do that. So there are a couple of ways you can do. So you can do it just in the traditional Pythonic way where you say, okay, import this other person's script and then run it in your main script. Or I believe you can reference kind of a script. If this person had been using Studio.ML as well, you can refer to their script through the experiment key that they had. But yes, you can use, you don't have to kind of, well, MNIST was a really simple example, which is why I just had, all of the pre-processing of the data and the training and the inference all in one go. But obviously you can break that up and just have one big main script that calls all of these different codes. Yeah, So future work. Oh, right. So I forgot to talk about this. So there's, so zoo.studio.ml is the web UI that you saw. It keeps track of experiments. So you can see other people's experiments and things of that nature. If you are just, using vanilla Studio with our storage, what we'd love to do is kind of similar to how there are different pre-trained models in Keras or PyTorch or TensorFlow. It'd be great if we could share kind of these pre-trained models and the artifacts and things like that through Studio. So for example, I don't know, there's this SSD paper, single shot, it's like a bounding box paper, and there's not a pre-trained model in Keras, which is what I've been using a lot recently. And so my coworker actually had trained a model in Studio using SSD, and I was able to go and use his pre-trained model to build an extra model on top of that. So it'd be cool if we could just, populate more of these models, pre-trained models that other people can use. And maybe a future thing that we'd love to do is add feedback to these models. So, you can like other people's models, I don't know, add a cat emoji or something like that.
Okay, we're coming up to the time now, so we appreciate everyone's time. We will be having additional webinars in future that go into slightly different use cases for Studio.ML. So please stay tuned. We'll keep you informed. But, you know, as Stephanie said, you know, if you have any additional questions, please reach out on the Slack channel or email us at team@studio.ml. So,
Yeah, or GitHub issues.
or GitHub issues. Yeah, thank you.